Okay, so we have one last video with a application problem, so something maybe in the real world. So the volume of a rectangular solid. Now a rectangular solid is like a box. I think we've seen those before. And a box has length, width, and height. So the volume of a rectangular solid is the length times the width times the height, just so that we know that. Okay, so the volume of a rectangular solid polynomial is given, the volume of a rectangular solid is given by the polynomial there. Okay, so that's the volume. Okay, so we could say our volume is going to equal something. So 3, I'm using this formula right here, 3x to the 4th minus 3x cubed minus 33x squared plus 54x. And then I need to know like the length, the width, and the height. Okay, it says the length of the solid is given by 3x. Okay, so there's the length. And the width is given by x minus 2. So there's the width. So this is like the L and the W. Find the height of the solid. Okay, so we're supposed to find that h. Okay. The first thing we're going to do, and we haven't had an example recently of this, but we're going to divide both sides by 3x. Now you might be tempted to multiply that 3x in, like why didn't I distribute? It's going to be a lot easier if I go this route. So I can divide this by 3x. And this is a concept, I think we've done it before, but I just want to like make sure I explain it here. So you're taking each term and dividing by 3x. That's a monomial. So we don't really have to do the long division or the synthetic division. It wouldn't really work for synthetic division, right? Because it's not in the form. But you're taking each term and then dividing that each by 3x. So like I said, I think we've seen this before, but if not, I just wanted to explain it. I'm just going to get the 3x out of there and divide each term by 3x. Okay, that's going to give me x cubed minus x squared minus 11x plus 3 into 54. I'll say 18. 3 into 5 ones, 24. Yep, okay. And then what do I want to do? I'm trying to solve for h, right? I'm going to divide by x minus 2. Now, we haven't seen it written this way before with the division bar, but this is your divisor, x minus 2, and then this is the dividend up here. Now, I'm going to go ahead and use synthetic division because this is in the form x minus k. And so I can use the synthetic division here. Plus I love synthetic division, but you can only use it if it's a linear divisor. Okay, so what is k? K is 2 this time. Put it in the box. I pull off my coefficients. 1, negative 1, negative 11, 18. By the way, I should check, is that in standard form or all the terms there? Yes, it's in standard form and it goes 3, 2, 1, blast off, constant at the end. Okay, so everything's there. That's great. I don't need any extra zeros in there. And I should have 4 coefficients because the degree was 3. So 1 more. Okay, great. Now I can do my synthetic division. I bring down the first number and then I do multiplying and dividing. So 1 times 2, that's 2. And then I add negative 1 and 2, 1. Then I multiply. 1 times 2, 2. Then I add negative 9. Negative 9 times 2, negative 18. And then I add 0. The remainder is 0. That means it divided evenly. And it means that k minus 2 was a factor. So that's exciting. So what is the height? This is what we were trying to find. Like, let me go back up here. Those were canceling, right? So that with my division here equals the height. The height is... well, I got to go down a degree. It used to be 3rd degree, so now it's going to be 1x squared plus x minus 9. No remainder. So, oh, I should have boxed the word height. Okay, but that's the answer, x squared plus x minus 9. So that was pretty fun.